Have you ever noticed when you've been drinking some raw pu'er teas that the first couple of infusions will have some sweetness, and then the last couple of infusions will have some sweetness too, but it kind of disappears in the middle. So why is that? Well, of course, the answer is molecules. So this is our raw Wild Mountain Pu'er tea, and this is the first infusion. I'm getting a sweetness to it, but it's not really a sugary sweetness. It's kind of a little different one. The molecule that's responsible for that, actually one of them, is called glycine. Glycine is the simplest and most water-soluble of all amino acids. It's also the smallest. Well, that's why it comes off on the first few infusions, because as I said, the simplest, the smallest, and the most water-soluble. As it's an amino acid, here's the amino part and here's the acid part, and then this is just one carbon with two hydrogens. It's small, it's short, it's water-soluble. It comes out and, well, there it is. There's some sweetness. In fact, in Chinese, this is actually called ganan suan, which literally translates to sweet amino acid. So that explains this one. Now let's take a look. This is brew number 15. Okay, that initial sweetness is gone. It's been now replaced by floral characteristics, the required little spike of bitterness and astringency, and we also get that characteristic cha-chi, which is the raw pu'er tea flavor caused by this molecule and hundreds of other ones. This is called coniferin. Now, let's take a look at brew number 25. Actually, this is my favorite part of the tea. This one and the ones preceding this and right after it. Okay, now I'm getting a sweetness in this. The cha-chi, that characteristic raw pu'er tea flavor, has subsided. The bitterness and astringency are gone, but we are getting a nice smoothness and sweetness to this. Where does that come from? It's certainly not this sweetness, because these amino acids, being so water-soluble, are gone. So what is that? Well, trees, tea trees being no exception, have found a way to make their storage most efficient so that they can push out the buds in the springtime so that they can start to photosynthesize and make more glucose. Well, they actually store glucose in the form of starch. Now, we'll explain this in a second. In starch granules. Starch granules are little boxes made of starch containing starch. And as you infuse, and you start to hydrate these very slowly, they will open, and you'll start leaking starch out. So let's take a look. What is starch and what is glucose? Okay, glucose is what plants make when they do photosynthesis. So this is just a molecule that is a very simple sugar, and there's only one of these. One of them, so it's not a chain of them, just one sugar molecule called glucose, and that's it. So this one will fit into your taste receptors. In your tongue, all over, you have sweet taste receptors. This is the right size. Here's the receptor, here's the glucose molecule. It's the right, perfect size to fit in there and fire that electrochemical response. Bing, you've had something sweet in your brain. So the molecule tells you that because it fits. It's this round peg in the round hole. But this isn't how plants store their glucose. This is too inefficient because you have to have water to solubilize this. So anyway, they link these together to make starch. And all starch is just a whole bunch of glucose molecules just linked together. Thousands and thousands of them. So if I were to put another glucose molecule here, let's take this off just really quickly and draw it. And okay, that's another glucose molecule. Now this is called maltose. This is actually, when you have two of them together, this is still a little bit sweet. But then when you add another one here, and then you add another one here, and then you add another one over here. Actually, once we start to add them up here, then it's no longer amylose. This is amylose. This is called amylopectin and becomes branched. It gets a little bit stickier. Anyway, this can be thousands of molecules long. And when it's that long and you have your taste receptor right here, this molecule won't fit in there. It is the square peg in the round hole. So there is no bing sweetness. There's nothing because there's no electrochemical response because your taste bud receptors haven't fired. So you don't get that sweetness. But in your mouth, thankfully, there's an enzyme called amylase. And this particular enzyme is a molecular scissors. So what it does is it cuts right here, and we've got a glucose there. It cuts right here, we've got another glucose. It cuts right here, we've got a glucose. It cuts here, we've got another glucose. So those glucoses, all four of those, get into that receptor, fire, bing, we sense sweetness. So as you're drinking this tea, that little micro amount of starch leaks out of the starch box, gets into your tongue, and then it gets cut up by that molecular scissor enzyme called amylase. And we make glucose, and then we drink the tea, and right away it cuts it up, and then we've got sweetness. It's the same kind of thing that happens if you ever had a cracker or a piece of bread or pasta, and then or white rice, you taste it. After a little while, it's like, well, that's getting kind of sweet. What is that? That's weird. That's starch. Well, that's the starch being cut up by that molecule, that enzyme, amylase, and it's making the glucose. So, next time when you're drinking your tea and you get this sweetness, say, thank you, amino acids. And when you're this infusion, thank you to hundreds of other molecules, including coniferin. And when you get to this infusion, say, thank you, amylase.